All right, hello everyone. So I wanted to introduce to you today Dmitry Shulayev. So I know him from my grad school years when I was a PhD student, and during that time actually Dmitry was doing master studies. So we were like working hard, doing a lot of research. We were also exploring the city, and I lost Dimitri for 3 years because he was in San Francisco, in California. So now we're kind of getting in touch back, and I'm as excited probably as you to hear what was actually happening over like the last 3 years. I was missing like all the conversations that we had during the lab. So that's also to let you know, like Professor Chris Collins is also on Skype. Hello, Chris.
Oh, he's
Or maybe he will be. All right. So during the talk, if you have like any questions, please just raise your hand and ask. But Dimitri is also very like ambitious. He actually prepared 112 slides. So let's see how many slides he will actually be able to go out of it. All right. So now I'm passing it to Dimitri. So,
all right.
Thanks for
Thanks
coming.
a lot. All right. Hi, everyone. My name is Dimitri. As Yarek said, it's absolutely great to be here. So once again, thanks, Yarek. So I've been somewhat working in the software development industry over the last 2 years. I finished my master's at York University, and then I worked on an experimental project of sorts. Then I went to California. I went to work at some startups. Worked there for about 3 years. I got quite a bit of experience working on different things. Mostly I worked on the back end. And for the last 4 years or so, my primary programming language has been Go. But in the past, I've used C++ and many others. But yeah, I wanted to come here and kind of tell you about my journey and some of the things that I've seen, and kind of maybe share some of the more interesting things, and show you some demos of the projects that I worked on, and share some talks that I think are really interesting. So if there's anything that you like in this, then I'll probably have succeeded, because basically I wanted to try to inspire you and show you some of the different things that are out there. So as I said, I also want to show you a little bit of Go. There will be two parts of this talk. So the first one, I'll introduce Go to you, but let's just get started.
You were talking about Jeremy Bradbury about Go, right?
yes.
So that's the other side of the Go. That's the person who actually loves Go.
Yeah. Let's get to that. So I want to first ask, since I don't know, what kind of programming languages have you guys used? What have you heard of? What are your favorites? Just let me know. Shout them out. Java, Python, okay. C++, C Sharp. Yeah. Node, of course. Yeah, which ones do you actually like? Like, show some excitement.
Java.
Java, you like that? C++, okay. What about front end? Like, what kind of languages have you used there? So that's in the browser. JavaScript, yeah, that's a big one. It's HTML, okay. So let me give a little bit of a preface here. So at this time, you're in your second year, as I understand, and it's a perfect time to try as many different languages as possible, and make sure to keep an open mind. It's absolutely great to have that. Don't be afraid to use what you like. If there's something that you really enjoy using, use it. As far as Go goes, it definitely is somewhat unique. And I personally think that knowing it or about it can give you a bit of an edge. It's kind of like a secret weapon, because for certain things, it can be very productive, and you can do things that other people could not. So let me talk a little bit about Go. You may have heard of it. It's my personal favorite programming language right now, and I think you guys will like it too. So here's a quick demonstration. This is the homepage. This is what it looks like. And it's described as a language that makes it easy to build simple and reliable and efficient software. So what is it really? It's basically an open source project that consists of its language specification, a small runtime. There are two compilers that actually compile Go. And this is the official project, but there's actually more compilers that I may get to at the end. A batteries included standard library. So this is a big one. The standard library of Go is extremely capable and extremely powerful. So if you look in there, you'll find things that you would have to look really hard for elsewhere. This is all in the standard library. It has really good tooling and documentation. They take documentation very seriously, and it's very pleasant to read it. if you were to ask me, what is Go about? I would say that Go is about composition. So what I mean by that is it is object-oriented, but not in the usual way. And there are no classes in Go. There's no subtype inheritance, so there's no any kind of hierarchies of classes. Another thing is that interfaces are satisfied implicitly. So if there's an interface that has a bunch of methods, then any type that has those methods will implicitly satisfy. You don't have to actually say this type implements. This can become pretty powerful. So the result of all that is that you have simple pieces that are connected by really small interfaces. And that can lead to good software development practices. Another aspect of Go is that it's about concurrency. So it provides very good concurrency primitives in the form of lightweight threads, and they're called Go routines. There's typed thread-safe communication and synchronization, which is channels. And as a result of these things, it's possible to have really comprehensible concurrent code. Finally, Go is about gophers. So they come in many shapes and forms, but they're very important. So again, the core values of Go. What's that? Right now I have 2. I want to get more, but definitely working on improving that collection. So these are the 3 values, the core values: composition, concurrency, and gophers. You can keep that in mind for now. Here's a simple hello Go program. It's just a hello world that prints something to standard output. So it looks like this. There's a package main that defines what kind of package this is. All code is always in a package. So main means that it's going to be a binary that you can execute as opposed to a library. You import thumped in this case. It's for formatting text. And then you declare the main function where you just say println hello Go. So if I run that, this presentation software lets me run Go code and then shows me the output right here for convenience. You can see that it works as expected. So I did mention that Go can be very powerful in certain ways, and this is a quick example of that. So this is a hello web sample. This is an entire web server that will have a handler. So here at the top of main, I register /, which means the top route. I give it handler. So this is the handler that will respond to all HTTP requests at that place. So if I just modify this to be, say, hello UOIT, and I can run this, so it's going to be hosting at localhost 4000. So if I hit that address, I will see it right there. So I just wanted to show you quickly how easy it is to start something like a web server in Go and how little code it can be. And another cool thing about this, if you're using the latest version of Go, this will actually be hosting HTTP 2.0, the latest HTTP protocol, without you having to do anything extra for that. So this will be quite difficult to achieve, for example, if I were to do this in C++. But let's get into the actual details of the language. I'm just going to hide the top bar. So this is a more low-level sample that I'll get more into the details of. So it imports a few packages, and at the top of main, we have net.listen. So it imports the net package, and it calls the listen method function inside there. So this will open a TCP socket that will listen on this address. So just a plain TCP socket. If there's any kind of error, we're going to basically bail out. And then this is a essentially for loop that loops forever, so it's kind of like a while loop, except 2 characters shorter. And inside of that, we're going to create a new connection by doing l.accept. So this will block until a connection comes in, and once it does, we're going to get a connection and an error. Again, if there's some sort of error, we're going to bail out. And then we're going to print hello to that connection and close it. So if I run this, then I can use netcat, just a simple utility to connect to a TCP socket. So if I do that, I get hello as expected. I can do this multiple times. So that works. Let's make this actually an interesting thing happen here. So I used the thumped package to print to a net connection, to a TCP connection. So how did that work? Well, the answer is it's all in the interfaces. So this is one of the features of Go. Because the fprintln is defined to write to an io.writer, and writer, which is in this IO package, it's an interface that has this method write. So this method takes p, a slice of bytes, basically an array, and returns the number of bytes it has written and an error. But the connection that we're using, it is also an interface that has all these methods, and one of them is write. So as a result, we can pass connection to println, and it'll just work. So even though the func package knows nothing about networking, but it knows about I/O, these two separate components can work together. So let's make it a little bit more interesting. This is going to be an echo server. So what I've changed here at the bottom is now, instead of just printing hello, it's going to take whatever input you send to that socket and copy it back to you. So if I run this, let's do another connection here. So now that I've connected, I can start typing stuff. So you can see it echoes back what I've said. Now, does anyone see a limitation or a problem with the current code? Any ideas? So the problem is this will basically block forever. This will copy whatever is being sent on that connection. So until this finishes, no other connections can be accepted. So if I connect from a different place, you can see that nothing happens here, but then when I quit, it starts to work. So the program is sequential. It only handles one connection at a time. How are we going to fix it? How are we going to make it work on multiple connections? Well, that's right. We're going to bring in Go support for concurrency here, and we're going to use Go routines. So they're the lightweight threads that I mentioned earlier. So the way that they work is there's a Go keyword in the language. So you basically want to put that in front of a function call. So in the main here, I've used Go on these 3 function calls, and say is just a function that takes some text, a string, and a number of seconds as an integer. And then the function say will sleep for that many seconds that I've passed in, and then after that it will print the text. So in main, I'm starting up 3 Go routines. The first one will print let's go after 3 seconds, this after 2, and after 1, and then it'll just sleep for 4 seconds to make sure that everything runs. So if I run this, you'll see that it works as expected. That means that to make that echo server that I've shown previously concurrent, we literally have to add 3 characters to the source code. The letter G, O, and space. So when we do this, every time there's a connection that's been accepted, it will spawn a new Go routine that will start copying in its separately, and we are welcome to continue looping, accepting more connections here. So I can do this again. And both of them work. All right, so let's get into a little bit more of an interesting example. Who here knows what Chatroulette is? So for those of you that know, you'll be pleased to hear that this is a text-only Chatroulette. So basically, we're going to have a program where a user connects, another user connects, and everything that once they're paired up, once whatever user A types, that'll show up in user B screen, and so on. So basically, they can chat with each other. But let's talk about the design of this application a little bit first. It's going to be very similar to that Echo program that I've shown before. But in Echo, we basically copied the connection's own input, incoming the data back towards that same connection. But for chat, we're going to take these 2 separate connections and then kind of copy one's data to the other and vice versa. But here's the thing, copying that data, that's the easy part. Just like in real life, the hard part really is finding a match between 2 partners. So here's a little diagram that will outline what I'm planning to do here. So right here is the Echo server. This is what we've seen before. So the main go routine runs and it keeps accepting connections. And every time a connection comes in, it will spawn a new go routine and will start IO copy that will just copy into itself. A second one comes in, it will also do this IO copy. So the chat server will be a little different. Now, instead of calling IO copy in the go routine, it will call a function called match. And match will do one of two different things. So actually, once there's two potential partners, there will be two go routines running this match function, and they'll have a brief conversation to decide what's going to happen. They're going to see that one of the match functions will decide to pass off its partner to the other match function, and the other one, and it will also basically shut down. This go routine doesn't do anything afterwards. The other one will accept the incoming partner, and now that it has two of them, it can just basically start running a chat function, and the chat function will basically do copy from one to the other and from the other to the first one. So let's talk about channels because we're going to need that to implement the match function. Yep.
For the previous slide, when you had the two match functions, how is the code going to decide which one's going to be the one searching and which one's going to be
Right.
the one?
So that's exactly what I'll get into next, and you'll see how it works out. So it will work through the use of channels. So Go routines in Go, they typically communicate via channels, and a channel is basically this sort of typed conduit, kind of like a Unix pipe, that can be either synchronous or asynchronous. But essentially, you can think of it like this. A channel can either be sent to or received from. So look at this fibs function here. It's being passed a channel. And in Go, you always read from left to right. So this is easy to read. This is a channel of integers. That's what CH is. So that's it's passed. And then this function basically starts with I and j that are 0 and 1. And then it loops forever. And then it tries to send a value, j, into the channel CH. So on the other hand here, inside of the main function, we're going to create this channel. CH is a new channel of integers. We're going to start a Go routine with fibs. We're going to pass it this CH channel. And then we're going to loop 20 times, and then we're going to print the value that we receive from the channel. So basically, this right here is sending J to that channel, whereas this right here is receiving J from the channel. So the syntax here is the arrow basically indicates the direction of the data flow. The J goes into the channel, and here the value comes out of CH. So when I run this, this prints the Fibonacci numbers. Channels are useful on their own, but with a select statement, they become extremely capable. So a select statement, it's very similar to a switch that you might be familiar with from the languages like C, but it will select over channel operations instead. And key point is we'll choose exactly one of them. So let's look at this example. In main, we're going to use the time package and some utilities there to create two channels. Ticker will be a channel that a value will be sent on that channel every 250 milliseconds. Essentially, and boom will be another channel where after 1 second a single value will be sent. So now that we have these two channels, we can loop forever, and we're going to select between these two possible cases. We either receive from the ticker and we print tick, or we receive from boom, and then we print boom and we just return. So what you'll see happen here is that every 250 milliseconds tick will happen because a value will be available from this channel. In that case, will be selected. But then once boom has a value available, this will happen and will return. So if I run this again, see if something happens. So we are seeing 4 ticks right now. All right. So that works fine. But remember, the key part here is that a select statement will choose exactly one operation. So now we're going to modify that echo client to create this chat program. So now instead of doing go IO copy, it's going to be go match. So let's look at match. This is what you asked about before. So here's how match works. this match function will use this select statement. And there will be two cases in it. So one case is we're going to try to send the C, which is our, our connection here that we're dealing with. We're going to send that to a channel called partner. So partner is a channel that we've declared globally, and it's available for everyone. And now we're either going to try to send our connection off to the partner channel, or the other case is we're going to try to receive from partner and have a value P. So if there are two match functions running at the same time, what ends up happening is that only one of them is able to send that value and the other one can receive it, or vice versa. But those are the only two possible outcomes. And so when we do this, we know that once that select statement has passed, then the partner has been found for a given connection. So the conversation itself becomes pretty simple. This chat function will print to both of them, found one, say hi, and then we'll start two copies. One of them in a go routine, and the other one will be blocking. So let's do a little demo of that. All right, so this is a simple chat program. I'm going to connect to it here, and it's saying waiting for a partner. So nothing has happened yet. And then I'm going to connect from a separate session. And look, it said found one, say hi. So now they're both connected to each other. So you can see that it worked at the beginning, but one of the partners decided to leave, and this first partner doesn't know about it. They just keep on typing into the void, and nobody's responding. So I think we've all been there. Let's try to fix this. So what's happened is that we didn't handle the errors properly. So previously, when we started those two go routines that did the IO copy, what ends up happening is that eventually, if the connection goes away, the IO copy returns an error. But we never cared to check for that. And as a result, the other partner was never told about it. So we're going to handle the errors, and we're going to fix this problem. So when the conversation is going to be over, we're going to hang up on both the A and the B, the two connections that we have. So we'll do this by creating this little helper CP. And it's going to copy, just like before, but it's going to take this third parameter, which is a channel of error values. And once IO copy finishes, so it returns this error value, we're going to send it onto this channel. So the chat function will now basically do everything like before, but it'll start to go routines for CP. And then it's going to try to receive a value from error C. So now that means this will block here up until at least one of the two connections has an error, which usually means that the client just disconnected. And then once that happens, we're going to resume, and we're going to close both the connections. Let's try that. So when I close one of the connections, you can see the other one is also closed. All right. Yep. So this is really only the beginning of this application, and I borrowed these slides from another talk. This is actually one of my favorite talks about Go. I've seen this a while ago, and this is one of the talks that got me interested in Go because I saw that how little simple changes could result in such powerful operations. And this talk actually goes on further to use WebSockets, Markov chains. It actually has bots that learn. So like as two people are having a conversation, their conversation is being kind of copied over to a bot that learns from that conversation. So when a third person comes in and there's nobody to pair them with, a bot will come and start chatting and they're going to use Markov chains to have a human-like conversation, it gets really crazy really fast. And also using TCP, HTTP at once, all these things become relatively easy to do. So this is a talk that you can watch if you want to see more of that. It was given by Andrew Duran. He was on the Go team, and he works in Google Sydney. So now onto the second part of this talk. So this is going to be more about the journey that I've taken in the last 5 years or so. So I'll start at the beginning. I got into programming pretty early, and what got me really excited is the ability to create video games. Once I found out that you can actually make them instead of just playing them. I mean, playing them is fun, but I just felt that creating them yourself was even more fun. So started off by doing really silly things like this. This is like some of the earliest screenshots I could find.
Anyone started before? 16.
16? Yeah, nice. I mean, it's never too late, but started trying to do some diagrams and figure out a better way to structure my codes. I don't think this effort actually panned out, but I tried. This was a little game that I was working on. It was 2D, and the goal was that it's kind of like a side scroller. You had these worms that could move around on this terrain and fight each other, but it was using various polygons and it was supposed to be pretty cool. Didn't quite finish it. This was like supposed to be a penguin climbing ice cubes. This was way before Minecraft, and I was thinking now that, man, I should have pivoted in that direction, but no. It's too far away. I'll show a couple more examples. So most things that I've worked on in the past, I didn't actually finish them. And I want to show an example of the opposite. This is a game that I've actually finished. And I think it's really important to have this experience at least once. Whatever project you're working on, whatever you're doing, just get it all the way to the end. So I'm talking about having like an actual options page here, so you can adjust the visual quality, the game difficulty. Yeah, this is a game made in Flash. Yep. It also has things like high scores. So once you have that, you know you're done. And the game itself, oh, and also this worm in the background, it's actually using some sort of AI right now, so it tries not to hit the walls. I can try to play it a little bit, but hey, it's actually not too bad. So I'm not going to keep going. But you can see this is a more or less finished game, and this is definitely a great experience to get to this point because, having something that works as a prototype teaches you a lot, but going from prototype to an actual finished product teaches you so much more.
That was Dimitri age 18? 17?
This was 2003, I think. It was a while ago. All right, this is another example I'll show. This was supposed to be also a 2D game. It's really hard to do 3D, especially for a couple of people. So this was a Counter-Strike clone, except top-down view, but you could run around and try to shoot people or bots and other stuff. So here I'm controlling this guy, and what's interesting about it is there's this field of view. So as I walk around this corner, I can start to see what's around the wall, but I couldn't see it before. So this gives it a very realistic sort of feel, and you can actually move around and try to find things. So I've added some bots so I can actually shoot at them. Yeah, none of them are smart, so I'm okay right now. There's also a second gun, which is kind of this invisible smoke grenade explosion thing. And you don't want to be caught in the blast radius of that. Now, what made this more interesting is the fact that I spent a lot of time making this work over the internet. So it has a pretty sophisticated networking model, so you could actually have two people play across, from two different points of the country, and it works really well. I've learned lessons from the Half-Life networking model and Quake and kind of combined the best of those two. So this was written in C++ at the time. It's relatively big, but I'll maybe get back to this later. So let's move on. But yeah, as I mentioned, I ended up kind of moving towards C++ as my language of choice at the time because it was fast, which you need for games. It was cross-platform. You could develop on multiple platforms. I kind of cared about that even back then, but I do more so now. And primarily, it compiled native binaries. That's something that I felt I really wanted to have that. So that was my main reasons. So later on, I went on to do my undergrads, my master's degree. So when I was deciding, should I go for master's or not, that was a time where I still wanted to do game development as a profession. That was kind of what I thought I wanted to do at the time the most. And I had a hard time deciding, I mean, do I go for master's or no? So the way I kind of made that choice is I looked at the two options, and they were both really good, but I saw that this opportunity to do master's was actually really great at the time. And also, I just wasn't that sure that I wanted to do game development. I had some hesitations. I had some doubts. So because I wasn't completely sure, I thought that let me just try master's and then have the opportunity to try something, learn, and figure out what I want. And also, the job market wasn't so great at the time. So my master's, I did it in the field of computer science, obviously, but I specialized in 3D graphics and user interfaces. So this was pretty relevant to video games, and I got to learn quite a bit in that facet anyway. So let me do a demo. This was my final project for the master's. The idea of the project was to work on a way of manipulating objects in a 3D space. So I'm gonna open up SketchUp. This is a 3D modeling / architecture kind of program. It's a pretty simple one, but it's pretty capable. So here's a pretty simple scene. And imagine that you have this scene and you want to move some objects around. Like there's that cube, and I want to place it on the shelf. So in this program, there's actually a very sophisticated tool for moving objects, and it's very powerful. But in order to use it, you both couple people have used it. Yeah. So it's a great program, but if you just want to move things very quickly, this is not the most efficient way of doing it. So what we came up with was an alternative way to move objects in 3D space. So let me show that to you. So this is slide. So this is a very similar scene. So to move an object, I click on it and I drag it. And as I do that, it slides on the surface it's on. And if it disappears, it just pops to the front. So as I do that, it feels very much like drag and drop, except in 3D space. So it makes it very easy to move objects around and position them roughly where you want them. Put this in the wall, move that a little bit. And none of the objects end up hovering in air, which in this case I didn't want to do. So there's a lot of tech that went into making this work and making it work well, but the end result is that it gives a very simple user experience, and studies this performed really well. Like it was not even close in terms of performance against the alternative methods that we tested against. But an interesting thing came from this experience. So as I worked on this project, this was also done in C++, as you can see here. This was a pretty significant project, and as I was making progress, there were many times where I was deciding that I want to change the direction of how I'm performing this operation or how I'm approaching a given problem. And I wanted to refactor the code. I wanted to move some functions. I wanted to rename classes. And as I was doing that, I mean, at that time and even today, the refactoring tools for C++, they're not that great. Some other languages have much better ones, like C# or Java, but C++ is still pretty tricky. And I was using Visual Studio. This is Xcode. It's nowhere near as easy as it should be. So I've realized over time that there's something that was really, frustrating me and also, motivating me to try to do something about it. And it was this idea that, there's no way that I thought this is what programming should be like, or this is how, this is as best as it'll ever be. So I wanted to keep using C++, but I knew that I wanted to do something about how I use it. So I also realized another aspect to this, that even though I liked video games, I think they're a great hobby. They're fun to work on. There's a lot you can learn from building them, and they can be fun. But I thought that one of my goals of making video games was that I wanted to kind of help people in a certain way. Like there's probably some games that you may think of that have these sort of deeper meanings. For example, like Braid had a pretty subtle one, and then some of the Hideo Kojima games, like the Metal Gear Solid, they have some interesting political undertones there. So I wanted to make a game where the player plays it, and then once they finish it, they want to become better human themselves. But I realized there's probably a better way to help people than that, and that's just by helping them more directly. I wanted to, after doing all that, I wanted to make tools that actually help them do their job. As I was using, these tools that I had at my disposal, I realized they could be so much better. So there's another talk that I want to share with you right now, and I would say this actually, like, if there's one thing you take away, it'd be that consider watching this talk. It is one of my favorite talks. It was given by Brett Victor, and it's a talk that's about sort of following a guiding principle. Now, in the talk, he gives a few demos of various user interface tools and experiments that he's done. So he's a very technically impressive guy. He made some, he worked on prototypes for various UIs at Apple and so on. He has a lot of experience and knowledge, but he also had this thing that was like his passion that was really driving him. And he showed really impressive demos, but also concluded with an interesting message. So I'll just try to summarize some of that, but really you should watch this. It's both impressive and very educational. But he noticed this one thing. As people go into university and as they go into industry after that, or for more academia, there's usually kind of two paths that are they're made aware of, that everybody knows about. And they're the paths of sort of the craftsman, which is kind of a person that just specializes in using certain technologies or certain skills and just practices them. So like if you're a programmer and you work and you have a project and you do your best to become a good engineer and get that accomplished, that's kind of what you do. And that's what most people do. That's a very popular path. And the other path is sort of the problem solver path. A problem solver is somebody, and this has two sides to it. This could be going into sort of the startup world, making your own business, or it could be in academia. You could be researching a problem that's no one ever solved before. You're trying to kind of push the boundary of the human knowledge. But what Brett talks about is this third path that is rarely mentioned, and that is kind of a different path where you're following sort of a guiding principle, something that you feel is guiding you, and perhaps when you look at the world, you realize there's something about it that doesn't feel right to you, and you need to do something about it. So I felt like this kind of resonated with me because it gave me a way of kind of explaining what I was feeling. It's that I was using these tools for working with C++, and I knew that there's no way that this is the best we can have, and I wanted to do something about it. So I felt so strongly about it that I kind of decided to just drop everything else and do this. And I wanted to work on this project. It was an experimental project where I just wanted to take C++, build on top of it, and kind of follow a principle of not having to repeat my work. Where in C++ you have your CPP files and your header files, and you would have to kind of do the same thing in both places, and quite a few other places where you just have to kind of manually repeat some step. I wanted to do better. And let me do a video. There's not going to be sound, but I can just annotate it. This is like a 4-minute video that shows what this project was about. So let me again say that this was a very experimental project, and my goal here was just to try different things and better understand why is it that we're still using text editors that haven't really changed in the last 30 or 40 years, and we still have our 80 width column terminals, and so much of computing hasn't changed. So it feels like, why hasn't it? Why is it there's not something different? And this kind of allowed me to prototype different approaches and also learn why or why not certain things worked. So let me show you the video. This was yeah. The idea here was that everything in Conception was made up of widgets. So these are 3 widgets that you're seeing, and they can be interacted with. And they're all located on this kind of canvas widget, which is kind of like a drafting table. You can zoom in, you can zoom out. It's this big surface area you can work with. And each widget, it's basically made from scratch and has certain rules for how it's displayed and has certain rules for how it interacts with user inputs. But aside from that, what it does or how it behaves is completely up to you. So the cool thing about these widgets is you could actually connect them together. So here's a text box that I could connect with this Go format widget. So as I modify this text box, it would actually modify, or it would automatically run formats on that to format this code. So here, this one button would create a gist for me. It would clone it to my workspace. It would put it in the right place. It would open it, and would just kind of let me paste a snippet here with one button press. This is something that I previously had to do manually, and it was pretty tedious. So this is a snippet that I'll use in the next example. It's going to come in handy. So this is a task where I basically want to write a Quine, a program that outputs its own source code. So I'll start writing it, and as I continue to write it, I want to see if I'm getting closer to my target. So I connect that source code to a Go run widget, so I can start to see what the output of the program is as I'm changing it. So I want to set a target for myself. The goal is that the source code and the output should be identical. So I've used the diff widget that diffs those two boxes. So as I make changes, I'm starting to see this diff update in real time as well. So I can see that as I'm making progress, that the diff gets smaller. So I know that this previous function that I've made is going to come in handy and make this process a lot quicker. So I've looked it up. This function will get me the source code, the path of the file where it's being called from. So I'm kind of cheating here and just looking up where the file is located on the file system. There it is. So now that I have that, I can just use IOUtil to read that file and print it to standard output. And there we go. Well, it's almost perfect, so there's a new line difference. So I'm going to fix that as well. And there we go. It's now exactly the same. So that was an example of something you could do with it. But the point was that how you use these widgets and various tools is kind of up to you. This was a widget that tries to kind of run a very small line of code. Here I was experimenting with representing concepts as individual objects instead of text. Let's see. Yeah, in this case, I want to work on. I want to modify a library, and it's being used by this program here. So I'm connecting in a few seconds the source code of this library, or sorry, of this command to that library. And the idea is that as I modify the library, this is actually going to modify or it's going to rerun the program and update its output. So I want to change something there, and I know it's at the bottom of the dump function, so I've zoomed out to find it. Here it is. So I can move them kind of closer together. And now I see that this is the library source code, and as I change it, the original program gets rerun, and I can see what I'm changing in the library have an immediate effect. And kind of gives me a better idea of what I'm doing. So I can also use a diff widget once again to make sure that if I'm refactoring my code, that the output doesn't change unintentionally. And what else is here? I can use external text editors, so it was a very flexible tool. Yeah, you can see that it picked up the changes from there as well. Well, this is the conclusion part where I said that the way you use these widgets, it's kind of up to you, and the ones that you create is also up to you. So it's kind of very flexible. It just gives you these a set of tools, and you just use them to answer various questions that might be popping up in your head. And I was saying that it's open source and you contribute to it, but this is now a deprecated project. I don't actively work on it. This was kind of like a great platform for me to experiment with various ideas and learn about things, but it's not something that eventually will become something that everybody uses daily. But nevertheless, there were really interesting insights that came out of that. So another thing that happened. That's right. So Yarek knows what's coming. I submitted this to a contest that was being held at this live 2013 workshop and ended up winning first place. So this felt really good. This was a contest for various demos that used live programming techniques. And the first prize was actually $500 cash. That was nice. But in addition to that, it was a chance to go to California, San Francisco, because that's where the conference was, and they paid for my flights, and they made me come there so I could give a talk. So this was actually my this was my first visit ever to San Francisco, and I kind of had been dreaming of making this happen because I know that so much of tech it's kind of centered around San Francisco and the whole Bay Area. So they kind of call it Silicon Valley. All the companies are there, right? Like there's Google, there's Microsoft, they have their offices, there's like GitHub, Twitter, everybody, all the small startups are there. And this city is kind of known for its sort of culture of just being all about tech and making progress. So I wanted to see what that's like. This was the first time that I saw the Golden Gate Bridge, and I can tell you that seeing that the ocean, the sun, the ocean breeze, and the bridge, it felt really, really awesome. The weather is basically sunny and around 20 Celsius most of the year. It varies very little, so it's fantastic. I mean, it's one of the reasons they're so productive there. They don't have to shovel the snow or anything like that. Snow slush. So this is another view. So another thing that came out of this, it actually helped me land my first job, and this was at a startup in San Francisco. It was a company called Trigit, or startup Trigit. And the company was basically in the ad business and was doing real-time retargeting and was doing a bidding on the Facebook platform, which was kind of new at the time. And what was interesting about them for me is that they had this really varied code base. They had some C++ code, they had Ruby, Python. They basically had every language under the sun. It was kind of spread out. But they had a problem. The main bidder, which was kind of the core of their business that kind of made all the decisions about the real-time bids, was basically created by one person, the CTO of the company. He was the genius and he knew how to do it, but nobody else could make a change to that. So they kind of tried Go on one of the projects they had written in Ruby, and it was very old, very inefficient. Some engineer rewrote it in Go in about a week, and it was his first time using the language too, but he basically made it all concurrent, and that program was basically like 100 times faster. It was crazy. So once they had that good experience, they decided to start to translate some of their additional code bases into Go as well. So they kind of saw that I had this experience with C++, with Go, and that's why it was a good fit. So I'll tell you a little bit about the startup life, some of the takeaways that I got from that. I knew this right away, but it's definitely very, very true. If you want to get better as a software engineer or whatever it is you're doing and whatever it is you want to get better at, you want to surround yourself with people that are better than you. So once you do that, and assuming you're motivated, it becomes really, really easy to learn. It's one of the best ways to learn. And you can actually use kind of Twitter for this. It's pretty hard, but if you just follow people that are actually, your sort of heroes or people that are really interested in being productive instead of just talking about other things, it can be really cool. I mean, you can be following somebody like John Carmack or Elon Musk and kind of see what they're thinking about. So this can be very inspirational. An interesting thing that happens is that usually when an engineer comes into a company, this is true even if they're more of a senior engineer versus a junior one. So usually what ends up happening is that initially the company is investing into that person because they're new, they don't yet know how to do anything. So it takes a while to kind of get them up to speed. But that's okay because
salaries in California like 140, 150.
yeah, it's 6 digits, pretty impressive. They definitely pay well. But yeah, as you get in, you at first are producing less value, but over time you get more experience and you're actually bringing back to the company way more than that salary. So it may feel kind of scary at first. You're getting all this tons of money, relatively speaking. There's many benefits, yeah, and that's okay. So what ends up happening is that the company will eventually benefit much more from whatever work you're doing there than the salary they might be paying you. So that's okay, and that's just a way that it works out. So the third point there is the kind of the feeling of having your first program go into production. This is something you're probably not going to forget, But no matter how much you prepare for it now, you're working on your code. You thought that you knew your stuff, but it's a whole different ballgame once you know that this project you've written, you think you understand it well, but now it's actually being put into production. So now there's real value that depends on this code working, and if it fails, that means that the company is going to start losing money. You're at fault. You have to fix it. You're under pressure, and this could happen at any time, right? The code runs potentially 24/7. Yeah, so this can be very stressful at first, but that's also normal, and you eventually get to learn that most of the time, actually, if you've done your job well, the program will be successful, and if not, you'll be able to debug it and figure out how to do better. So this kind of happens at first, but it goes away, and it's part of getting that experience. But feels kind of good once you have it running successfully. So diagrams is something that we've used quite a bit in the companies that I worked on, and they're usually used for planning or sort of high-level architecturing of some sort of feature or some sort of mitigation plan. So when there's something you're doing except for just brute force implementing of a new feature, people usually get together and use whiteboards or other approaches, and you want to talk at a higher level about the problem you're solving. Nobody just gets into code. So one example I actually have is at my second startup at SourceGraph, there was a week where for that entire week, we had a couple remote people that came in, and we had this kind of idea of re-architecturing a pretty significant aspect of how it worked. So for the entire week, there was nobody really working on any features or writing codes. It was just days after days of planning at a high level, drawing diagrams. I think Yarek would have been really, really proud.
What you're saying is that UML is very important.
Very much so, yeah. So pay attention to what Yarek is saying. It will definitely happen, and that's kind of the more interesting part, because that's where you're really deciding how a program will be architectured, how it will work. The rest is just implementing it. Yeah, that can be fun too, but it's definitely not as significant. Okay, hiring. So this is actually a really hard problem. It turns out that many startups or companies that are in a position to hire more people, they have a really hard time finding those people. And if you're looking for a job, it seems like, oh, it's so hard to find a job, but it's kind of the same for companies. And I've been on that other side too. So I'll actually share a few stories about that. But also another kind of statistic, and it's pretty well known, that in terms of startups, about 1 out of 10 will have a successful outcome. And what I mean by that is this is an outcome where the company really grows big and it gets acquired by another bigger company, and basically the people that have either created it or founded it, or the early employees that have high amount of stock, they actually get really rich from that. So this is really rare, and also it ends up being that luck will play a huge role. So the first startup I was in, after 2 years, it was eventually acquired, but it was not favorable. And at the last couple of weeks or months, it's kind of interesting to see just how little is in the control of basically the people that have gotten the company up to that point, and how much of it is kind of the politics of other bigger companies and so on. So it wasn't a great outcome for Trigit. I was okay because I didn't have that much stock anyway, and I wasn't counting on it. So I had a great salary. That's what I kept. But of course, you feel bad for the founders that have been there for 5 or 7 years, and they really invested into the company. But that's the reality of it. The one successful one, it really kind of overshadows all the other ones that I've tried but didn't get that far. But some of the kind of cool sides of living that life is you basically have free lunches, free foods, you have coffee, whatever you want. There's so many perks, but on the flip side, you have to work pretty hard, and this kind of varies. But sometimes that means many long hours. So that's kind of the thing that you have to sacrifice to, make the startup itself successful. And as I've talked about, San Francisco itself, the weather is fantastic. The city is really interesting. There's many events. There's tons of meetups. If you want to go for a tech meetup or any other kind of meetup, they're really dense there. There's many, many things happening. Great food if you're into going to restaurants and enjoying that. But it has really high rents, and there's the homelessness problem because the weather's great, so they kind of end up flocking there. And yeah, it's kind of unfortunate to see like the really rich people, like they're getting into Ubers and like everything's paid for, and they're kind of living that lifestyle. But on the other hand, there's the homeless people. They're just on the street, and this like an individual can't really do much about that. But another interesting aspect of the hiring is hard thing that I've mentioned. So really, like if you think about a company that has lots of money raised, their goal is to create their product as quickly as possible. So they want to hire as many people as possible, and good people, but they want to grow. So this is a real life kind of example about a star. This is that kind of star. If you ever used GitHub, you've seen that projects can be starred, and it's just a way of like favoring it. And what happened is when I created that conception project and ended up winning the first prize, it ended up on Hacker News. This is a popular website. How many of you know it? So it's kind of like a place for tech news, and things kind of get uploaded that are most popular. So this was my conception project at the very top. And what ended up happening as a result of that is this guy right there, Artsy, he ended up leaving a star in the project. He thought it's pretty cool. So what happens next is that this person here, she was the technical recruiter at Trigit, an in-house recruiter at the time. And, it's kind of ridiculous when you think about the way that hiring ends up working out. But what she ended up doing to find more people, like she literally did this. She went to, this person's profile, and she looked at all the projects that he had started and kind of saw, okay, like, let me try to reach out to these people. And as a result, she was able to find me and then reach out to me. And that's how the conversation started. And that's how I got my first job, just because of that first start. So, this shows just how much luck has a role, how much of a role it has. But also, like, if you work hard and you have something that's visible, then people are likely to notice that. Yeah, very quickly, I'll also mention another really talented engineer I know, a friend. He's somebody that's he was working. He was living in Victoria Islands in Canada, close to British Columbia, and basically he wanted to get a job somewhere in the Silicon Valley, in the Bay Area. So at first he had a round of interviews, and he ended up joining Evernote. So he worked there for about a year, and then at Evernote they had some trouble. Ended up that some people were basically asked to leave, and he was one of those people. So when he was doing that first round of interviews, he had a lot of good offers, but he ended up choosing Evernote because that offered the best package. So then he went for a second round of interviews, and I know this guy. He's one of the brightest people I know. He has actually interviewed at one of our companies, so I know that he's really good at taking an interview, and I was very impressed. So we actually wanted to hire him, but the same company that offered him a really competitive offer the first time, they really wanted to bring him on board. They were actually fighting for him. The second time, they were not interested anymore. And he actually had a really bad run. Like he applied at, I think 4 or 5 or 6 companies, and he interviewed, and he thought he did well at some of them, but he ended up not hearing at all. And that was really frustrating. But he ended up taking a couple weeks, and he went for yet another round of interviews. And after that, he got offers from Microsoft and Google. So this goes to show that somebody that's really, really good, it's still kind of a matter of luck. But the way I kind of look at it is, if you're going to an interview and you do the best that you possibly can, and you've done a great job, you're basically contributing to maybe 50% of whether or not you'll be able to end up there, if you'll get an offer. Because the other half, it kind of depends on the company and their internal situation, what are they thinking and what are they doing at the time. So of course you want to do well, but basically you can't guarantee anything. So that's why you need to end up applying to many places. So I'll go on to talk about some open source. So I'm pretty prolific in open source these days, and I've always liked it. But the reason that I really enjoy open source, the idea, and participate in, is because I feel pretty strongly that open source is great because anybody can contribute to it. Nobody's locked out. So if somebody wants to make something better, they can. On the other hand, the problem with proprietary software is that unless you're at that particular company, you can't contribute. You can't fix a problem that you might be experiencing. So if there's a problem with this MacBook that I might want to look into, I can't be at Apple but also at Google at the same time if I also want to fix a bug in some Google proprietary software. So that's why I always end up looking towards the open source solutions. And this is me on GitHub. So I've got quite a extensive profile. You can see I've contributed quite a bit, and have a lot of projects right now with many stars and so on. And I've contributed quite a lot to my personal projects, but also to other people's projects, and so on. Somebody made a tool that basically takes your GitHub username. How many of you are familiar with GitHub? Before I go on, so most of you know about it, right? It's just a place to kind of put your code, and a lot of the projects are there right now, so people can collaborate. So this is basically a page that shows all the pull requests that I've ever made with this username. So you can see that there's quite a bit. Go4JS is a project I'll maybe mention. I've contributed to Google's Go GitHub library. This is their API client for GitHub. Many others, and you can see this goes on and on and on. So another thing I've done is on my personal website, I've created this kind of really detailed activity feed. So you can actually see that yesterday, I commented on this issue in this repository. I said that, so I commented. So yesterday was a lot of commenting, not so much code. I merged the pull request. Yeah, I haven't. There's. After this, probably, yeah. And that's kind of the thing. I wanted to make this for myself because I'm curious, and also if somebody wants to know what I'm doing, you can actually literally see in real time, these are the events that are coming in, what I've done. Let's see. And so why contribute to open source? What's in it for you or others? So I think one of the main reasons people do it, or one of the best reasons to do it, is because it's something you need, something you want. So if you're using a library and it's not a library you've made and there's a bug in it, would you rather just make a hack that you have to kind of maintain locally and try to keep it up to date as there are newer versions, or would you rather just try and fix it upstream so that this benefits you but also everybody else at the same time? I think it's more efficient to do the latter. Another aspect is that it's a great way to improve your skills. You can also, basically by working with others, by collaborating, and some of the people that you may work with are really good, you can learn from them. You can build their reputation. So by having a really, public profile like that where you've worked a lot, it makes hiring so much easier. So if a company wants to hire you, they can just look at what you've already done. They don't have to kind of rely as much on seeing what you're going to do during the interview. So it really makes it much easier to find a job in the future. And there are different ways of contributing. It's not just writing codes. There's many other things you could do to help a project. If it's something you care about and you want to make it a little bit better, it could be just triaging things, seeing if you can reproduce it, and so on. All that helps. Writing code, of course, but it's not the only way. And when you're in the open source world, it's really normal that you want to test the waters first. Your first contribution, it's never going to be this giant thing it's really valuable and so on. So I want to give an example. This is my first contribution to the Go programming language itself. Let's see. So this was my change. It's literally a single line. It was using this new slice. And I knew there's another variable that could be used instead. So I just simplified the code a little bit. And that was okay. So that got merged in. And now, on the other hand, my fifth commit is quite a bit more extensive. So this fixes issues in 2 packages. It has a pretty lengthy commit message. This describes the motivation and what's actually going on in this change. And if you look at the code, it's another pretty significant change that went into the core source code of the Go project. So I couldn't have gotten to this point without having started with a smaller one first, because you want to get familiar with the owners of the project. How are they receptive to you contributing, and what that experience is like. And maybe if you want to contribute, this project might be dead. Nobody will actually merge your pull request. So don't do something big right away. So a little bit about the Go community. So I found, for me at least, that with Go, it was kind of the first programming language where I felt there was a community. It's probably because I was coming from C++, which is really divided. There's not one C++. There's like all these different ways of using it and so on. But yeah, with Go, it's great. There's conferences, there are meetups and talks, and they're all very specific to Go. And because Go kind of encourages people to have a unified style, that means that the way that I write Go code and the way that somebody else writes it is probably going to be very similar. And if I read that code, it'll be as if I wrote it, and it's very easy to communicate. So that makes the community aspect of it pretty strong as well. So I've had some nice accomplishments in terms of like, getting to meet some of the people from the core Go team, like the people that have actually created the language. So this was at a meetup in San Francisco where I met Andrew Duran for the first time. That's him right there. So he's actually that guy from Sydney that gave one of the first talks that I mentioned at the beginning of my presentation. This was another person that's also pretty significant in the Go project. He contributed a lot of the graphics and mobile packages. It's David. This was a pretty cool moment. So the language Go was co-created by 3 people: Rob Pike, Ken Thompson, and Robert Griesmer. And this right here, this is actually Rob Pike. So he's one of those 3 people. And this is Renee French. She's his wife, but she's also the person that created the Go Gopher. So like the design, the original design, and a lot of the thinking and the way that the character behaves or interacts, it's kind of like her creation. And this is Francesco Campoy. He's also like an advocate, halfway on the Go team. He's also on the Google Cloud team. So it was great to actually get to to meet them in person. So yeah. So as far as what I'm doing right now, so as Yarek has mentioned, I'm actually back. So I'm no longer working at the startups. So the reason I was there, part of the reason was I wanted to learn. I wanted to become a much better software engineer and kind of surround myself with the best people that I knew of, and pick up as many skills as possible, like just get as good as I could. And at the same time, I've always wanted to contribute as much possible and work in the open source world, as opposed to working for a proprietary, in a company on a proprietary project. So this includes personal projects, but also contributing to the Go itself. There's also Go for JS. I'll maybe briefly mention it, but how am I doing on time?
I'll probably do 7 minutes and leave 5 minutes for questions.
Okay. Yeah, and the kind of like the current plan is, so the thinking is that when I was working in San Francisco those 3 years, I've saved up some money so that I can actually do this now, and basically spend some of that money now to work on open source, which doesn't pay at the moment as much.
Some money is very good money.
Yeah, I mean, it helps also if because my goal was to work on these kind of projects. That's kind of what I wanted to do. It helps to kind of save money towards that, as opposed to spend a lot of it on food or something else that I may not get as much out of. But yeah, initially right now I'm working on projects that I think are important. Things like WebAssembly, or things that I really want to tackle first. But in the second half of this year, I'll probably work on or think about certain ideas that I could work on that would actually lead to some profitability, so I could actually continue to do this for a longer amount of time. And we'll see how that comes out. But yeah, I'll do another a quick little bonus slide, actually a couple of slides. Let's see here. So this bonus here, it's about browsers and Go. The situation that I found myself in is that I wanted to use Go, but web development is so prolific and browsers are around us that it's really hard to ignore them. And they currently support JavaScript primarily. There's not really much of a choice there. But I've realized that Go, it actually supports quite a wide set of platforms. So you can already target different desktop operating systems with Go. You can build for Linux, Mac OS, or Windows. It also builds on these unusual ones, as well as mobile operating systems like iOS and Android. That's officially supported. And if you look at the entire list, it's pretty significant. So what I was thinking is, how about adding one more? What would it feel like if we had a Gopher inside the browser? So He really wants to get in. And there is an answer to this. So a project called Go4JS, this is a compiler that compiles Go codes into JavaScript. As crazy as that sounds, but the goal is that it lets you write Go code, which will then run inside browsers. And the interesting thing is that it works surprisingly well. It's originally created by 2013 by Richard Musoil, and he's done most of the work. He got everything except Go routines running initially, then Go routines came, and there was a caveat that he fixed, and then there's nothing to do in terms of like making the compiler feature complete in the last 2 years, just minor enhancements. So the project has gotten a lot of attention, and because I think it's both really cool but also really important, I contribute as much as I can to it to make it go advance forward. So it has many stars, many watchers, and many commits. This is a pretty complicated project, but you can actually see that it works. Here's a quick example. So this is a Go4JS playground. So this is actually running. The compiler itself has used itself to compile itself into JavaScript, which then runs inside the browser, and I can now compile more Go codes into JavaScript, which will also run. So it's kind of mind-bending this way, but the interesting thing is that it works, and I've used it pretty much exclusively in the last 2 years. I've stopped using JavaScript just because I found that this works so well for my needs, and I've started to enjoy it so much. So if I go to my website again, so I have some projects here. Let me show you. Let's see here. Let's see. This will work. So this is a 3D game that I worked on. This is written in Go. Oh, no, that's the wrong one. So it's kind of like this hovercraft that has a little terrain, and you can kind of fly around, and there's some physics that make it a little bit more interesting. So this is written in Go, and right now it's running on this Mac directly. But what's interesting is that because it's written in Go in such a way that doesn't do anything too crazy, the Go4JS compiler can pick it up, compile it, and then I can use it inside of a browser. So I'm going to use Safari for this. Projects. I'll just go there. So I actually have a whole bunch of projects here if you ever want to check out some of them. But this is the hover demo itself.
And I will pause the slides after the lecture so you have access to all the links.
So you can see that I'm in Safari. And trust me, I did not write any JavaScript to make this possible. But this is that exact same code base running at probably close to 60 frames per second. And it works just like you've seen it work before. I've worked on, you remember the EXO, the Counter-Strike clone thing? So I've also worked on rewriting that in Go. It's not as feature complete, like there's no textures or anything like that, but the networking part of it works. And because it's written in Go, I can do this. Now this is that game working inside of their browser. So I told you that it's multiplayer, right? Go CD. So I'm gonna connect to it from my desktop. So this is a client that's running in the browser. This will be a client that's running natively on Mac OS. Let's see if that works. All right. So as I move in one of them, you can see that it's being updated in the other. All right, I'll stop here. If you have any questions.
So thank you very much. Thanks for a beautiful talk. So I really enjoyed it, and it brought memories of the conversation that we had in the grad school. But it was also nice to catch up what you were actually doing after.
Yeah, I was glad to talk about
it. Is Chris still on the... All right, so any questions? Martin first.
The graphical limitations.
So what's the most advanced thing that you would be able to accomplish using Go?
Got it. Yeah, so good question. The underlying technology that's being used there for the actual graphics rendering, it's called WebGL. Have you heard of it? Okay, so it's using WebGL 1.0, which is not the absolute latest. There's now WebGL 2.0, but they're roughly pretty similar in sort of capability. WebGL 2.0 lets you do some of the things a little bit more efficiently. But there was a demo in the past. It was done by the Epic team that made the Unreal games. They've actually ported the entire Unreal Engine to run inside the browser. That was using WebGL 1.0. So that's as far as you can go. Yeah.
President of CS Club.
You mentioned how you like that you want to work full time on open source. How do you find like a balance between putting all your time towards open source and actually like at the end of the day taking home maybe like a salary, right?
Yeah, good question. So that's something that I'm still in the process of figuring out. I've got a current plan, which was I've saved up enough money that I don't have to worry about money for some amount of time. But like I said, that's not sustainable. So I want to find maybe there's some project that I could create that can have this kind of side income that could fund my future development process. But maybe there will be something else, or like basically the worst case scenario for me, or not worst case, but like the safe fallback will be eventually I just find a job and do this again. We'll see how it works out. But yeah, I'm definitely interested in finding some other interesting ways of making that happen. But it's an exciting time.
All right. Any other questions? So, yes, Michael.
So maybe one thing I didn't hear you touch on, but is Go similar to like C++ in terms of like for memory you can use it any way you want? There's no like garbage collector or anything like that?
Yeah, it actually is kind of the opposite. It has a garbage collector, so you don't have to manually manage the memory. So unlike C++, where in C++ you do have to like allocate and then free. So one of the reasons why that was done, I would say, at least in my mind, is pretty clear. It was done to enable the kind of concurrency primitives that I've talked about. So one of the things you may often see is that like if people really optimize a given snippet of codes to work really fast, the C++ solution usually ends up being the fastest. It's has the least overhead. Go will often come very close. But if you look at a very realistic case where, say, a person is given like a week to work on a project and they use C++ versus Go, the thing is, oftentimes with Go you'll be able to implement something much more efficient that makes better use of your computer's resources in that 1 week time span. So it'll actually perform better. And if you think about today's CPUs, they're like 3 gigahertz, 4 gigahertz. They're not getting faster per core, but they're getting wider. There's more CPU cores available. So this actually, I think, puts Go in a very favorable position because you're able to make much better use of all the CPUs that you have available to you.
All right. Second question.
During your time as an undergrad, what kind of open source projects were you contributing to, and do you have any projects that would be good for us to contribute to as well?
Yeah. Great question. I'd say that actually I had very little that I've done back then, because that was sort of the time where I was still primarily using C++. There was one project which I both used but also tried to help and contribute to, and that was GLFW. So this was the kind of the project that I used to create a window, get keyboard mouse input from it, and would let me do basically draw graphics and so on.
But you can contribute to the new project.
Yeah, I'd say really the best thing to do is find something you're actually using. Like it's kind of hard to just find something to contribute to because that's what you want, but instead have something you want yourself and then find something that would benefit from your contributions as a result of that.
I'll pause the slide so you can be in touch in the future via email, like if you have any questions.
Yeah, and honestly with Go it's much easier to find projects to contribute to than with C++, in my experience. Mm-hmm. Yeah. So when you say one task, do you mean they're told something like,
you are given
like a specific area.
Take care and you don't know anything
Yeah.
outside of it.
Yeah, it definitely happens much
You
more
can be
in.
stuck for a lifetime.
Yeah, it happens much more often in big companies. This probably could happen in a startup too, but does not happen nowhere near as regularly. Just because a startup will typically have like a much smaller team, say 5, 10 people, maybe bigger, but unless it's actually a huge startup. So if you're 10, 20 people, chances are you have to wear many hats, you have to know everything, and you want to be really well-rounded, so you will have the opportunity to work on much more. That's very much guaranteed.
So I have last question because it looks like it's also a very motivational talk. That it's actually worth working, and we actually had this conversation about hitting the bricks, if you remember, in the car when you're driving. So what would be actually the message? Because actually not in this course, but in the other course, like 2072, like the other was just like 36%, right? So the moral is a bit down, but believe me guys, like in 5 years you'll not even remember that. Like in my life, and also I think Dimitri shares the same philosophy, just always work hard. The worst you can do is to give up. If you give up, you'll fail. But as long as you'll be working hard, things will connect.
Yeah.
So what would be actually the message from you to like, from all the years and your experience, like what was the thing that actually brought you where you are?
So I'd say, like really, that kind of message would be that, you want to find something that really inspires and drives you and hang on to that and make the most of it, because that is the most unstoppable force. Like find something you're truly passionate about, and then also realize that you as a person have choices. You can kind of like shape your life to go in the direction you want. Like you're in control. Sometimes it's hard and you have to work hard for it, but you can achieve what you want. So find something you really want to do, make it happen. You can do it.
All right, so thank you very much.